All right, let's get right into it. Today, we're talking about a real clash of the titans in the Python data world. We've got Pandas, the reigning champ, everyone knows. Then there's Polars, this new speed demon that's turning heads. And finally, Dask, the absolute master of scaling up. This is the DataFrame battle you've been waiting for. So picture this. You've got a Pandas script, right? It works, it gets the job done, but man, it takes, let's say, 45 seconds to run. You just kind of accept it. Then a colleague comes along, rewrites the exact same logic in Polars, and boom, it runs in 3 seconds on the same machine. So you're left thinking, what on earth just happened? How is that even possible? Well, today we're going to pull back the curtain and find out. Okay, before we get to the how, we need to meet the players. Let's get to know our 3 contenders. First up, we've got the legend itself, Pandas. I mean, if you've touched data in Python, you've used Pandas. It's been the undisputed king since way back in 2008. So, the best way to think about Pandas is like a single, incredibly talented chef. This chef is a master. They can whip up anything you ask for, they're super flexible, and they play nice with all the other tools in the kitchen. Scikit-learn, Matplotlib, the whole crew. But, and this is the big but, this chef always works alone. Pandas was built to use just one of your computer's CPU cores. And as you can imagine, when the dinner rush gets heavy, that one chef kitchen starts to feel the strain.
And then, crashing onto the scene, we have Polars. This is the challenger, built from the ground up with one thing in mind, pure, unadulterated speed. It's the new kid, and it is fast.
Okay, so if Pandas is that one amazing chef, Polars is a whole team of chefs, all working together in a perfectly coordinated kitchen. It's written in Rust, which is famous for performance. And here's the kicker. It automatically uses all the CPU cores on your machine. You don't even have to ask. It just divides up the work and gets it done in parallel. It's a total game changer. And it has a little secret weapon under the hood called a query optimizer, which we'll get to in a bit. And rounding out our trio is Dask. Now, Dask is a little different. It's here to answer a very specific and very scary question. What do you do when your data is so massive it literally won't fit on your computer?
Let's go back to our kitchen analogy. If Polars is a team of chefs in one kitchen, Dask is like a giant catering company. We're talking about coordinating hundreds of kitchens all across the country for a massive global event. Dask's whole purpose is to take the tools you already know and love, especially Pandas, and let them work on datasets that are way too big for your computer's memory. It does this by splitting the job across a whole cluster of machines. I mean, their motto says it all: scale the Python tools you love.
All right, you've met the contenders. Now it's time for the main event. Let's see how they handle a simple, everyday task, reading a big file. Let's talk speed.
Whoa. Okay, just look at this. We're reading a pretty hefty CSV file, 10 million rows. Pandas comes in at just under 10 seconds. Dask is right there with it, but then look at Polars. A little over 1 second. That is not a small difference. That's the kind of speed you feel instantly. And it gets even crazier when we look at writing the data back out. Polars, 3 seconds. Pandas, 35 seconds. That is just a world of difference. Dask is a bit slower because it has to manage all its moving parts. So let's break it down. Polars is roughly 7 times faster at reading and more than 11 times faster at writing. That's huge.
Okay, so numbers like that, they don't just happen by magic. There's some serious engineering going on here. It's not just that Polars is written in a fast language. The real secret is in how it works. So let's pop the hood and see what's going on.
So the first big secret is something called lazy execution. See, Pandas is, well, it's eager. The second you give it a command, it runs off and does it. Which sounds good, but it's like going to the grocery store for just one ingredient, coming home, and then realizing you need another, so you go back. Super inefficient. Polars, on the other hand, is lazy. It listens to all of your instructions first. It's like you're giving it the full recipe. Then it sits down, looks at the whole thing, figures out the smartest way to do it all, and then it goes to the store once with a perfectly optimized list. Much, much smarter. The next piece of the puzzle? Parallel processing. Remember our chefs? Your computer has multiple processors, or cores. Think of them as individual chefs ready to work. Our Pandas chef, bless its heart, only uses one. Polars comes in and puts the entire team to work, all at the same time. It automatically splits up the job so every core is busy, getting the whole thing done way, way faster. It's teamwork, pure and simple.
And this is where it gets really clever. Polars doesn't just run your code, it thinks about it. It acts like a smart database. So you give it a whole chain of commands, right? Read this file, then filter for these values, then group by this column. Polars looks at that entire plan and asks, what's the absolute fastest way to get this done? For instance, instead of reading a whole massive file and then filtering, it's smart enough to only read the rows it actually needs from the disk to begin with. That's called predicate pushdown, and it's just one of its many tricks. It does all this optimization automatically and then unleashes that super efficient plan across all your cores.
So after all that, should you just throw out pandas and use polars for everything? Well, not so fast. It's not that simple. The real answer is it depends on the job. So let's talk about how you choose the right champion for your fight. Okay, here's the simple guide. When should you use pandas? When your data is pretty small, let's say under a gigabyte, or when you're just doing some quick interactive exploration. Its huge ecosystem is also a major win. But when performance is everything and your dataset fits on your machine, that's Polar's time to shine. It's the king of single-node speed. And what about Dask? You bring in Dask for the truly enormous jobs, when your data is way bigger than your computer's memory and you have to scale out to a whole cluster. So at the end of the day, this isn't about hype or just jumping on the latest bandwagon. It's about being a smart craftsman. It's about looking at the shape of your problem and picking the right tool for that specific job. There isn't one winner. There's a winner for each specific type of workload. All right, let's take a step back for a second and think about the big picture here. Because what's happening with tools like Polars is more than just a speed boost. It's a sign of a much bigger change. This quote from one of the creators of DuckDB really nails it. For the longest time, the solution to big data was more computers. You'd build these huge, complex clusters. But things are changing. A single modern laptop or server is now incredibly powerful. And tools like Polars are designed to squeeze every last drop of performance out of that single machine. We're getting to a point where one computer can now handle jobs that, just a few years ago, would have absolutely required a whole cluster of them. It's a pretty wild shift. And so that leaves us with a really fascinating question. If a single machine today can do the work of a whole cluster from 5 years ago, what does big data even mean anymore? What does that change about the tools we need, the money we spend on cloud infrastructure, and maybe most importantly, what new, bigger problems can we now tackle? Something to think about.